Hello, I'm Mr. Brewer. I teach physics at Seven Lakes High School. And lately we've been talking about reflection and refraction. Reflection is what happens when you look in the mirror. Flat mirror, what you see is what you get. You can have a flat mirror, you can have a concave, or it's like a makeup mirror. Anyway, then you have refraction. Now refraction is where light's bend. It goes from one area, air, through another medium. Medium, that's air, water. Medium, I'm not talking about large or a psychic. I'm talking about different material, like air, water, space, and so forth. That's transparent, that light can pass through. Lately, we've had a scenario of Dr. Gonzo, okay, the big-time, well-known scientist, is wanting to tag Charlie the tuna. No tuna is harmed in the making of this illustration here. Let's see what happens here when we talk about index of refraction, shall we? Let's listen. All right. So we have light bouncing off of Charlie. Charlie, of course, is down here in the water here, and it's bouncing toward the surface of the water here. Here you have Gonzo on the boat looking for Charlie to tag him. Keep in mind, this is for scientific purposes, and Charlie's going to be fine. Okay? So first of all, what index of refraction is basically it's the ratio of how speed of light changes in a medium. So first of all, we compare it to C, which is speed of light in a vacuum, which is 3 times 10 to the 8th meter per second, approximately. V refers to the velocity in which light passes through water or air. So that's how we come with our index. So it's index of 1 for air and 1.33 for water here. So what happens here is this. We have light bouncing off of Charlie going to what we call a normal here. And we have what we call angle of incidence. That's where the light off of Charlie is coming perpendicular to a perpendicular line called normal in the water here. So what happens here is basically light's going to go from a greater density, greater N, to an area of less N or less density like air. So what happens here is I'm going to decrease my N. By decreasing my N, I'm going to increase my velocity. So what happens here is velocity increases as it hits the air here. So what happens when it hits the air, it's going to bend away from normal. Now normal, of course, as I said, is perpendicular line right down the middle here. So angle of incidence is where it's reflecting off of Charlie, and it's hitting the normal here, and it's bending away from normal. So this angle here is going to always be larger than this angle, as long as it's going from a greater density area to a lesser density area, because it'll go a lot faster. Try riding in water sometime and see how much it slows you down compared to air. Same idea. Okay? So in order for this to look at this, we have our index of refraction is light's going to bend away from normal. So as light speeds up, as it goes from water to air, it's going to speed up and it's a bend toward normal, or bend away from normal rather. Whereas if it's looking the other way around, where Charlie's looking at Gonzo now, and the light's bouncing off of Gonzo into the water here, that means light's going to become this way, the reverse way, which I have drawn here, and therefore it's going to slow down. If it's going to slow down, it's a bend toward normal. So in this case, is Gonzo going to see Charlie? Is Charlie going to... Well, we'll have to find out. But what would happen, what would it look like if Charlie and each other saw each other? So we're back to like Tom Hanks and Castaway. You know, he's trying to spearfish those fish here. He kept on missing them. This is why. Let's look a little closer. So what happens here is this. So in order for Gonzo to tag Charlie, he actually will look into the water and actually he'll think he sees him here. That's the dotted line. He's not really there. He's actually here, but because of angle of refraction here and angle of incidence here, how the light's bouncing off, and the index ratio here of index of refraction, he knows that Charlie should be, although he appears here, is actually here. So in order for Tom Hanks to hit those fish, or in this case, the Gonzo to help Charlie out, the tuna, he's going to actually have to aim low. By aiming low, he will actually take into account the angle of refraction and everything, and the index of refraction. Well, we can go on and on about, but the idea is we keep on investigating, keep on asking questions, and remember, always, always, always keep physics fun. Thank you.